In this video, we'll work with a project app where we'll write unit tests as well as an integration test using Jest and Test Utils from the React DOM library. We'll learn to use Jest, the default test runner that comes pre-installed and configured with the Create React App toolchain. We'll also learn to set up tasks to run before and after each test. We will also learn to use the act function from the test utils, mocking functions and API modules, simulating user events, writing expectations and matcher functions, and snapshot testing. So let's get going. Jest is an incredibly easy test runner that can be used to write tests for JavaScript apps. It is maintained by an open source team including employees from Facebook. As you can see from the headline on their homepage, Jest is not restricted to React, but can be used with other libraries and frameworks besides testing vanilla JavaScript and even TypeScript code. Jest ships with JS DOM, a JavaScript-based headless simulation of a browser DOM that acts like a sandbox to run your components in for testing. In essence, Jest provides us with the tools to write test suites and define expectations from code and to validate them using matcher functions. You saw a glimpse of Jest in the last video. But besides Jest, and when working with libraries like React, we also need special tools to render components and applications in a way that provides complete access to React features. When setting up a toolchain using the Create React app, a special edition of Jest comes pre-configured and ready for use with the test utils from the React DOM library and the React testing library. So out of the box, you can start writing tests without any setup whatsoever. Therefore, in this video, we'll use Jest and the test utils from the React DOM library to test a to-dos style React app that comes with a backend API server. We'll write unit tests for two components, testing them in isolation, and an integration test for the app where we'll use snapshot testing to ensure an intended rendered outcome. Begin by downloading and extracting the folder. You'll get an API server and a folder with the React app. Run npm install in both the folders, followed by running npm start in the API folder as well as in the CRA to-dos folder. This is required to see the app in full before we write our tests. Here we have our tasks app, which we had used in another module in the course. You can add tasks, mark them as done, and delete them as well. We'll unit test the add to do component, which renders this input field element that sends up the contents of the input using the onAdd prop when the user types something and hits the enter button. This is then handled by the onAddHandler function, which uses the add-to-do service, which then works with the API server that I have up and running on port 8080. The API server uses the JSON server package to quickly spin up a file-based server. You can see the file here. If I add a task, it gets added to this array named to-dos. Marking this as done toggles the done flag. The add-to-do component renders an input field with event listeners. When the user types and presses enter, the onAdd prop is invoked as a function passing in an object with the title and done properties. The title is the task definition, while done is a flag that denotes task completion. At this time, the input field is cleared as well. We will also test the status button component, which displays the status of task completion and allows users to toggle the status besides testing the app itself using the app component. Okay, the first thing we need to do is organize our tests into a folder named __tests__ inside the src folder. This is important because this is where Jest will look for when we run our tests using the npm tests command. So begin by creating this folder. We'll first write unit tests for the add to do component. So you will have to create a file in the tests folder named addtodo.test.js. You could also name the file addtodo.spec.js. The naming convention is important here, so make sure you write the file in exactly the same way. Before we write the test case, let's understand what this test will evaluate. Defining the intent of your test case is important to be able to write them effectively later. So for the add to do component, we wish to test two things mainly. Type a task, then press enter, and the component should invoke a function in the onAdd prop, which provides us with the task string that the user has typed. Upon pressing enter, the input field should be cleared out and reset. Once the expectations are defined, the next task is to understand how this test would work. The first thing we'll do is create a simulated test surface in which we'll render our React component. So imagine a div within which we'll render the component in isolation. This would be achieved using the test utils from React DOM. Once rendered in this simulated environment, we get access to DOM selectors just like in the real world, so we can select the input field to type in. Next, we'll simulate typing in some text and pressing enter. At this point, we will be able to run through our expectations and their outcomes to see if the component behaved as intended. If it does, our tests pass, or else they fail. At the end of every single test, the simulated test surface has to be torn down and removed from memory. With this understanding, let's proceed to write the test suite. I'll begin by importing React, since this is needed to render any component that uses JSX. We'll also import the render and unmount component at node methods from the React DOM library. The render method will be used to render the component in simulation, while the unmount component at node method will be used to tear down the React component once we are done with the test. Now we need to have a div to render the component into. Note that there is no browser involved in this process and the browser DOM is simulated instead. So we'll first create a variable named div and I'll set it to null. I'll then create the before each and after each functions. These functions can be used to define actions that should be performed before every test and after every test respectively. In this case, before every test, we will create a div using the document.createElement function and we will then append it to the document.body like so. This is how you would insert an element when writing JavaScript for the browser. So before a test runs, we've built a test surface, a div into which we'll render our React component. Now after each test runs through, we'll use the unmount component at node to remove the component instance from the div, and we'll remove the div itself before setting the div variable to null once again. This process is then repeated by Jest every time a test runs. We can then write our tests. We'll first use the describe function, which helps us define a group of tests. You can thus write multiple groups of tests for various features of a component or an application depending on complexity. We'll just write a single group named testing add to do component because that is what we're doing. Within the describe function's callback, we can use the it method to write our actual test cases. So first test case is going to test if our component returns the contents of the input field using the onAdd prop. This will be an async function because we will be performing asynchronous tasks such as simulating rendering, typing and pressing the enter key. Now, first up, we need to render our component in the div we have created. For this, we'll use await and the act method where we can use an async callback to render the component into the div like so. The act function is required to wrap all individual operations that you want to do on your component. Now, let me import the act function from the React DOM/test utils, and we'll also import the component. Now, add to do has an onAdd prop, which we have to test. In a React app, this would be bound to a function which consumes the task string from the component and use a service function to store it in the database before updating the state. Here, there is no such thing. So how do we test the outcome of a prop? One way is to plug a mocked function, something that is in control of Jest. So first, I'll create a mocked function, and we'll do this using jest.fn, as you can see here. This is just an empty function with no internal logic, but this is something that we can now plug into the onAdd prop and keep an eye on it as it is called. Now once the component is rendered, we can use standard DOM selectors such as document.querySelector to get hold of the input field because we want to try and type in that field. So to do that, I'll create yet another act wrapper like so, where we'll use the simulate method from the test utils to first simulate the onChange event like so. We are using await because this returns a promise. As is evident from the statement, we are targeting the input field using its selector, and we are using target.value to set a string. This is a test task. Next, we'll again use simulate to simulate a key up event for the enter key with the key code 13. I'm sure you can see how readable the test is so far. So now comes the time when we write expectations and match them with outcomes. This is done using the expect method from Jest. So expect the onAdd function because remember this is the function that we plugged into the onAdd prop. Expect this function to be called with the object here. The to be called with function is known as a matcher and is one of several easy to understand matcher functions that can work with expect. If you try to read this statement, it makes logical sense as well. Expect this function to be called with this result. The object that we have passed is what our add-to-do component sends back when the user types and presses enter. Now comes the moment of truth. On the terminal, I'll type npm test, which runs Jest, and our test passes with flying colors. This green badge with the word pass is what you're aiming for with this entire exercise. When we run npm test, Jest runs in watch mode, which means that I can edit my code and tests, and the test will keep running automatically. So let's say an engineer comes in and changes the object which is returned from onAdd. Once the file is saved, the test reruns and it fails this time because it didn't get what it was expecting. More importantly, it shows you what it did not get. Let's test one more condition. Our input field is cleared out when the user presses enter using the set task statement here because the input field is a controlled component. Let's write an expectation to check this. All we have to do is say expect input field.value to be an empty string. Simple, isn't it? Save this, the test runs again and passes. If we type something here instead, then the test will fail, once again showing you what it expected versus what it received. So this was our test suite for the add to do component. Our next component is the status button component. Here we are testing two situations. If the status prop is set to true, then clicking on the component returns a false and vice versa. While this happens, we are conditionally overloading the class name as well to render an enabled and disabled button respectively. So let's write a test suite. In the tests folder, I'll now create a file named statusbutton.test.js. My test runner is still running, so you'll see the status button test failing because it has found a test suite file but it's got nothing inside as yet. To save time, I'll copy and paste this setup because this is consistent across all test suites here. I'll then import the status button component and we'll use describe to create a test group where we are testing the status button component. Our first test should ensure that the component returns true when the status prop is set to false and the user clicks on the component. So once again, we'll render the component as a necessary first step. I'll manually set the status prop to false for this test, and for the onDone prop, which we have to investigate, I'll once again set up a mocked function using jest.fn. We'll then grab hold of the status button div element using its class name. Then we'll use the act function wrapper and the simulate function to simulate a mouse click on the button. We are thus expecting the onDone prop to be called with true. So we'll use expect on the onDone fn with the to be called with matcher to see if that is the case. And our test passes. Next, we'll also test to confirm if the class name property is status-btn or something else at this point. Our test works. Next, I'll copy this entire block and we'll just flip the situation here. It should return false when the status prop is set to true. We'll flip all conditions and we'll check for the class name as well, which in this case would have been overloaded with the status done class, indicating an enabled button. This is necessary because if an iteration of the component involves accidental removal of the overloading class, the test would fail right away. And as always, it tells you what went wrong. Our final test would be an integration test where we'll test the app itself, where all components interplay and must work cohesively. We'll not build all possible test cases here for simplicity. Our goal here is that we want UI consistency, which is why we'll employ snapshot testing. We'll first demand that the app displays a few tasks that it pulls from the API, and we'll take a snapshot. Subsequent tests should ensure this snapshot for UI consistency. Second, we'll add a new task and once again take a snapshot to ensure it is added precisely where we need it to. I'll create a file named app.test.js to begin with, since we are testing the app component here, which is the root of the application. I'll replicate the setup which we have been using in other tests. Now, one key thing to note with testing is that as far as possible, it should not depend on actual data or networked APIs. Networked resources are often rate limited, slow, accessible only to authenticated users, and may just be unavailable due to some reason. This can cause your tests to fail. So instead, Jest allows you to mock your APIs and modules. The features that we'll test will require the use of the getToDos and the addToDo service functions, which in turn queries the API server. Let's mock these two service functions. In our test file, I'll type jest.mock and we'll point to the actual services module which exports the live service functions. This is known as mocking a module. Here we'll return our two functions like so. For our getToDos function, we'll return a promise which resolves with an array of two tasks like so. This way, we are setting base for an expected outcome. If this is what our app renders, our snapshot always succeeds. Live data, on the other hand, can change and snapshot testing can fail. The addToDo mock function will accept the incoming task object from our app and will return the same object after adding an incremental ID property, which I'll set to 3. This is how the actual API server also responds. Okay, let's start writing our test group now. Our first test case simply renders a successful snapshot. This means that our app in its default render should display the two tasks as provided by our mock function. We'll first render the app as always. And then I'll expect the div.innerHTML to match the snapshot. This is where the magic happens. When this test is run for the first time, Jest renders and stores a snapshot in the _snapshots folder, as you can see here. This snapshot is the escaped string version of the rendered UI. And you can see we have our tasks from the mocked API rendered in the snapshot. Now, every time the test runs, the rendered outcome is matched with this snapshot on disk to assess consistency. So for instance, an iteration changes the title of the app from tasks to task. The test will fail right away. We'll now create another test case where we'll first render the app. Then I'll grab the input field on the UI and we'll simulate typing in a task and pressing enter, just like we did in the add to do test suite. And we'll then take a snapshot. This time we get a second snapshot which does include the newly added task. This way our tests are portable, we have tested API interaction and UI consistency. This was testing the app using Jest and Test Utils from the React DOM library. In the next video, we'll work with the same app using the React testing library so you get a fair comparison of its benefits.